Hey guys, tonight we're traveling to the heart of the Inca Empire, to a city that sits 11,000 feet above sea level, where the air is thin and the history is thick. You might struggle to catch your breath at this altitude, but trust me, the real breathtaking moment comes when you see the walls, massive stone structures that have stood for 5 centuries without a drop of mortar holding them together. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, drop a comment telling me what city you're in and what time it is for you. I love seeing how far this community spreads across the world. Now, dim the lights. Maybe turn on a fan for that soft background hum. And let's ease into tonight's journey together. You're standing on a cobblestone street in modern-day Cusco, Peru. It's early morning, and mist clings to the surrounding mountains like a soft grey blanket. The sun is just beginning to peek over the eastern peaks, casting long golden shadows across the plaza in front of you. At this altitude, 3,400 meters, if you prefer metric, you feel lighter somehow, as if gravity itself has decided to take it easy on you. But you also feel the thinness of the air. Each breath takes in less oxygen than you're used to, and your body reminds you with every exertion that you're a visitor here. But your attention isn't on the altitude, it's on the wall beside you. You reach out and press your palm against a massive block of grey-green stone. It's cool to the touch, despite the rising sun, and it feels impossibly solid. This single block you can only guess, but it must weigh several tons, fit so perfectly against its neighbors that you can't find the seam. Not with your fingernail, not with the edge of a coin, not with anything you have on you. The stones have been shaped with such precision that they appear to have grown together rather than been assembled. Here's the thing that keeps historians and engineers awake at night. The Inca people who built this wall never used mortar. No lime-based cement, no gypsum paste, nothing to bind the stones together except the perfection of their fit. And yet these walls have survived more than 500 years of earthquakes, rainfall, and the slow erosion of time. Spanish colonial buildings built right on top of or next to these Inca walls have crumbled during seismic events, while the Inca foundations beneath them simply shimmy a bit and settle back into place as if nothing happened. You walk along the wall, marveling at how the stones interlock. They're not uniform rectangles like Roman bricks or medieval castle stones. These are irregular, polygonal shapes, some roughly square, others elongated, a few almost triangular, but they've been cut so that where 2 stones meet, their surfaces are perfectly complementary. It's like a 3-dimensional puzzle where each piece has been custom shaped to fit exactly with its neighbors. And the stones vary wildly in size. Some are small enough that one person could lift them, while others are the size of a small car, weighing perhaps 50 tons or more. Historians are still debating exactly how the Inca accomplished this. Some believe the stones were shaped using harder stones as tools, patiently chipping away over months or years. Others propose that the Inca used a technique called hammer and feather, a method so delicate that a misjudged tap could ruin hours of work. And then there are the more controversial theories involving plant-based chemicals that could soften stone, though mainstream archaeology remains skeptical of these claims. What we do know is that the Inca didn't have iron tools. They didn't have steel chisels or diamond-tipped saws or any of the modern equipment that today's masons take for granted. What they had was stone tools, bronze instruments, and an almost incomprehensible amount of patience and skill. The results speak for themselves. Walls that have outlasted empires, walls that modern architects struggle to replicate even with all our technology. You continue walking through Cusco's streets, noticing how the Inca walls form the foundation for much of the modern city. Spanish colonial architecture sits atop Inca masonry like a child perched on its parents' shoulders. It's a visual metaphor for how Inca engineering supports everything that came after, literally and figuratively. Many of these Inca walls were actually buried beneath Spanish rubble for centuries and only rediscovered when earthquakes destroyed the colonial buildings above them, revealing the incredibly resilient Inca foundations underneath. The street narrows, and you find yourself in what was once an important Inca ceremonial pathway. The stones beneath your feet have been worn smooth by millions of footsteps over 5 centuries. You're walking the same ground that Inca nobility walked, that Spanish conquistadors marched upon, that generations of Peruvians have used as a route through their daily lives. The continuity of it all is humbling. As you move deeper into the historic center of Cusco, the Inca masonry becomes more and more impressive. What started as impressive stone walls has evolved into something almost otherworldly. The stones are larger, the fits more impossibly precise. You're approaching the most sacred and impressive examples of Inca stonework, places that will challenge your understanding of what humans can accomplish with determination, skill, and apparently very little sleep. You've arrived at Hatunrumiok, the site of the famous 12-sided stone, though historians will tell you there are actually several such multi-sided stones in the area. But this one is special, and as you stand before it, you understand why people have traveled from around the world just to see this single wall. The stone before you is enormous. It's difficult to convey its scale through description alone, but imagine a stone block that stands as tall as a person, wider than you can span with both arms, and thick enough that you couldn't guess its depth without seeing the other side of the wall. And every single edge of this stone has been shaped to fit perfectly against the stones surrounding it. Not perfectly in the sense of pretty close, we're talking about joins so precise that a piece of paper couldn't slide between them. A human hair would be too thick to insert. You lean in close, examining the surface. The stone is a greenish-grey diorite, incredibly hard, the kind of material that would take modern cutting equipment hours to shape even roughly. Yet here it is, smoothed and shaped with curves and angles that match its neighbors with mathematical precision. You run your fingers along one seam, feeling for any irregularity, any gap, any indication that this is the work of human hands rather than some geological miracle. You find nothing. This is the moment when most visitors experience what archaeologists call the Inca wall epiphany, that sudden realization that you're looking at something that shouldn't be possible given our understanding of historical technology. The Inca achieved this without written architectural plans, without iron tools, without the wheel, without draft animals suitable for construction work, and without any knowledge of modern mathematics or physics as we understand them. They did it through accumulated knowledge passed down through generations, through trial and error, and through a worldview that saw stone not as inert material to be conquered, but as a living entity to be worked with. You step back and look at the wall as a whole. From a distance, the individual stones blur together into what appears to be a single, continuous surface. Only upon closer inspection do you see the network of seams, the intricate puzzle of interlocking shapes. The wall seems almost organic, as if it grew this way rather than being assembled piece by piece. The stones don't just sit next to each other, they actively hold each other in place. The irregular shapes mean that each stone is locked into its neighbors from multiple directions, creating a structure that distributes stress and weight more evenly than any rectangular block system could achieve. This interlocking design is the secret to Inca walls' earthquake resistance. When seismic activity shakes the ground, most traditional buildings crack at their weak points, usually the mortar lines between rectangular blocks. But Inca walls don't have mortar lines, and their irregular shapes mean that there are no straight, continuous seams for cracks to follow. When an earthquake hits, Inca walls actually dance. The stones move slightly, shift position as the ground rolls beneath them, and then settle back into their original configuration as the shaking stops. It's a remarkable feat of engineering that modern architects have studied and attempted to replicate with limited success. What's particularly interesting about these walls is that the most impressive stonework, the kind you're looking at now, was reserved for the most important buildings and spaces. Temples, palaces, and ceremonial structures received the finest workmanship. Less important buildings used rougher stones with less precise fits. The Inca weren't showing off for the sake of it. They were allocating their most skilled labor and precious time to the spaces that held the greatest religious and political significance. This tells us something about Inca priorities. The sacred and the political were intimately connected, and both were worth investing generations of skilled labor to honor. You notice something else about the wall. There are no visible tool marks, no chisel scars, no grinding patterns, no indication of how the stones were shaped. The surfaces are remarkably smooth, almost polished in places. This level of finish would have required additional work beyond simply shaping the stones for fit someone, or many someones. Spent countless hours smoothing and perfecting surfaces that would be visible. This wasn't just about structural integrity. It was about aesthetics, about creating walls that were pleasing to look at and satisfying to touch. The Spanish conquistadors who first saw these walls were similarly baffled. Many of them assumed the Inca must have had some supernatural assistance, because they couldn't conceive of humans achieving such precision with the tools available. Others recognized the skill involved, but couldn't understand why so much effort would be invested in what they saw as pagan structures. Their solution, unfortunately, was often to tear down the Inca buildings and reuse the stones for their own constructions, or to build directly on top of Inca foundations. That's why so much of Cusco's modern architecture sits atop Inca walls. The Spanish couldn't match the craftsmanship, so they built on what was already there. You find yourself wondering about the individual stonemasons who worked on this wall. What were their names? How long did they train? What did they think about as they spent hours or days shaping a single stone? Did they take pride in their work, knowing it would outlast them by centuries? Archaeologists have found evidence that Inca stonemasons were highly respected specialists, their knowledge passed down through family lines like a sacred trust. The most skilled masons worked on the most important projects, and their techniques were carefully guarded secrets known only to initiates. The sun has risen higher now, and the changing light reveals new details in the wall. Shadows emphasize the slight variations in stone texture, the subtle color differences between blocks. What appeared gray in the morning light now shows hints of green, pink, and brown. These aren't painted colors, they're the natural variations in the stone itself, carefully selected and arranged to create visual harmony. The Inca didn't just consider structural fit, they also thought about how the colors and patterns of the stones would work together aesthetically. You could stand here for hours and continue noticing new details, but there's more to see. The walls you've encountered so far are impressive, but they're only the beginning. The Inca Empire didn't confine their architectural genius to Cusco alone. Their engineering feats spread throughout the Andes, From Ecuador to Chile, each site adapted to local materials and conditions while maintaining that characteristic Inca commitment to excellence. As you stand before these impossible walls, it's worth taking a moment to understand how the Inca thought about construction, because their approach was fundamentally different from European building traditions. This difference in philosophy goes a long way toward explaining how they achieved such remarkable results with seemingly limited technology. In European building traditions, stone is essentially an inert material, something to be cut, shaped, and assembled according to a predetermined design. The builder imposes their will upon the stone, and mortar is used to fill the gaps where the builder's will hasn't been perfectly executed. There's a hierarchical relationship, human over material, designer over substance. The Inca saw things differently. To them, stone was a living entity, part of the natural world that deserved respect and careful handling. This might sound mystical, but it had very practical implications for how they worked. Rather than forcing stone into predetermined shapes and dimensions, the Inca approach was more collaborative. They would select a stone and then work with it, allowing its natural properties and tendencies to guide the shaping process. Each stone was treated as an individual with its own character, to be understood and worked with rather than dominated. This is why you see so much variation in the shapes and sizes of stones in Inca walls. European builders would have cut everything to uniform dimensions for efficiency. Inca builders allowed each stone to retain its individuality, shaping it just enough to fulfill its structural role while preserving its essential nature. The result is a wall that feels more like a community of stones than an artificial construction. This philosophy extended to the construction process itself. Rather than following detailed architectural plans drawn up in advance, Inca construction appears to have been more improvisational. Builders would have a general sense of what they were creating, but the specific shapes and arrangements would be determined on site as each stone was fitted into place. This required enormous skill and experience, the ability to visualize how a partially shaped stone would fit and then complete the shaping accordingly. It's a bit like sculpting from the inside out, where each new addition responds to what's already there rather than following an external template. The Inca also had a different relationship with time. Western building traditions typically emphasize efficiency and speed, getting the job done as quickly as possible within budget constraints. Inca construction was notoriously slow by modern standards, but this wasn't due to inefficiency. It was a deliberate choice to prioritize quality and durability over speed. A wall that would stand for centuries without maintenance was worth investing years or even decades of careful work. The Inca were playing a very long game, and they understood that buildings aren't truly efficient if they need constant repair or replacement. Another key difference is the role of community and collective labor. Inca society was organized around the principle of mita, a system of reciprocal labor where community members contributed work on public projects. This wasn't slavery or forced labor. It was a civic obligation that came with expectations of reciprocity from the state. When people worked on Inca building projects, they weren't just following orders, they were contributing to something that would serve their community and express their cultural values. This sense of collective ownership and purpose may have contributed to the extraordinary care and attention to detail evident in the finished work. The Inca also had a highly sophisticated understanding of their environment. They knew which stones worked best for which purposes, where to find them, and how to transport them. They understood the seismic activity of their region and built accordingly. They recognized the importance of drainage and foundation work, even though these weren't visible in the finished structure. Much of Inca engineering expertise was about what you couldn't see, The careful site preparation, the deep foundations, the internal features that made the surface beauty possible. One aspect of Inca construction philosophy that modern archaeologists find particularly intriguing is the concept of kame, the idea that objects and places could be imbued with spiritual essence through careful workmanship and ritual attention. For the Inca, creating a building wasn't just a technical process, it was a spiritual act. The care and precision evident in Inca stonework wasn't just about showing off skill, it was about creating something worthy of the gods and capable of holding sacred energy. This doesn't mean we should explain Inca achievements through supernatural means. Rather, it suggests that the Inca were motivated by a sense of purpose and attention to detail that goes beyond mere utility. The Inca approach to construction was also remarkably adaptive. They didn't impose a single architectural style across their empire, regardless of local conditions. Instead, they learned from and incorporated the building traditions of the cultures they absorbed. The stonework techniques you see in Cusco evolved over centuries, incorporating influences from earlier Andean cultures like the Tiwanaku and Wari. The Inca were brilliant synthesizers, taking the best of what they encountered and combining it with their own innovations to create something new. This adaptability extended to the materials themselves. Inca buildings used whatever stone was available locally: granite in some areas, limestone in others, andesite or diorite where those were predominant. The techniques were adjusted to suit the specific properties of each material. What remained consistent was the commitment to quality and the underlying philosophy of respectful collaboration with the material rather than domination over it. Understanding this philosophy helps explain why Inca walls have such a different feel from other ancient stonework. There's a sense of harmony and integration with the environment that European stone architecture often lacks. Inca buildings don't sit on the landscape, they grow out of it, as if the mountains themselves were rising up to create shelter and sacred space. The walls feel less like constructions and more like natural formations that happen to be architecturally functional. You're beginning to see that these walls aren't just engineering marvels, they're expressions of a completely different way of thinking about the relationship between humans and the material world. The Inca didn't conquer nature through their architecture. They worked within nature's constraints and possibilities, creating something that feels both artificial and natural at the same time. To truly understand Inca stonework, you need to see where it all began, the quarries where massive stones waited for thousands of years until Inca stonemasons woke them from their geological slumber. So let's leave Cusco for now and travel several miles north to the slopes of a mountain where the raw material for those impossible walls was extracted. The journey itself is instructive. As you walk away from Cusco, following what would have been an Inca road, part of the vast network of highways that connected their empire, you notice that the path is surprisingly well constructed even here, far from major settlements. The Inca didn't do anything halfway. Even a simple road in a remote area was carefully built with drainage, foundation work, and durable surfacing. This attention to infrastructure would become crucial when it came to moving massive stones from quarries to construction sites. You're climbing now, ascending into the mountains that surround Cusco. The air is getting thinner, and each step requires more effort than it would at sea level. But the Inca were adapted to this altitude in a way that you, as a visitor, are not. Generations of living at high elevations had given them physiological advantages, and they were capable of physical feats that lowlanders found astonishing. Spanish chroniclers recorded Inca messengers running hundreds of miles over mountainous terrain in days, a feat that seems impossible until you remember that these were people whose bodies had evolved for exactly these conditions. The quarry comes into view, a massive scar on the mountainside where stone has been extracted for centuries. As you get closer, you see something that surprises you. There are stones here that are clearly partially worked. Massive blocks have been partially separated from the bedrock, their shapes suggesting the forms they were intended to take. Some have been completely detached and sit ready for transport, while others are still connected to the mountain, their extraction abandoned partway through for reasons we can only guess at. This is one of the most fascinating aspects of Inca quarries. The work appears to have been done at the quarry itself, rather than transporting raw stone to the construction site and shaping it there. This means that Inca stonemasons had to envision the final shape and dimensions of each stone while it was still part of the mountain, working it into approximately the right form before separating it from the bedrock. This required an extraordinary ability to think in 3 dimensions and to visualize how a partially shaped stone would fit into a wall miles away. You walk among the abandoned stones, marveling at their size. Some are modest, perhaps a few tons each, within the theoretical capacity of a large group of humans. Others are absolutely massive, easily weighing 50 tons or more, and a few are so large that you can't imagine how they could have been moved by human muscle alone. Yet, archaeological evidence strongly suggests that this is exactly what happened. The Inca moved stones weighing up to 200 tons using only human power, ropes, ramps, and levers. The quarry walls themselves tell a story. You can see the marks where stones were extracted, the patterns of extraction that suggest careful planning rather than haphazard removal. The Inca didn't just hack away at the mountain, they selectively extracted stones that suited their needs, leaving the rest of the quarry face intact. This selective approach minimized waste and reduced the amount of work needed to shape each stone after extraction. You notice something else interesting. The quarry reveals the geological story of these stones. You can see the natural fractures and fault lines that the Inca learned to work with. Rather than fighting against the stone's natural structure, they extracted blocks along existing fracture planes where possible, making their work easier and resulting in stones that were less likely to crack later. This is another example of the Inca philosophy of working with stone rather than dominating it. The scale of extraction here is staggering. Archaeologists estimate that the major construction projects in and around Cusco required thousands of tons of stone to be quarried, shaped, transported, and assembled, all without iron tools, without draft animals, and without the wheel. The sheer organizational challenge is mind-boggling. We're not just talking about technical skill here. We're talking about logistics, planning, and the coordination of thousands of workers over decades or even generations. You find a partially worked stone and examine it more closely. The surface shows clear evidence of shaping smoothed areas where rough protrusions have been removed, edges that have been rounded or squared off. What's remarkable is that this stone was clearly being shaped for a specific purpose. The stonemasons who worked on it knew exactly where it would go and what role it would play in the final structure. They weren't producing generic building materials. They were creating individual pieces for a specific puzzle. The quarry also contains evidence of the tools and techniques used. There are hammerstones, harder rocks used to chip away at the softer building stone. There are bronze or copper tool marks, suggesting that metal instruments were used for finer work. And there are what appear to be grinding or polishing marks, indicating that some stones were smoothed after the basic shaping was complete. All of this work was done here, at the quarry, before the stones were moved to their final destination. You sit on a large unworked block and consider the logistical challenges. The nearest major construction site is several miles away, over rough terrain with significant elevation changes. Moving a multi-ton stone over that distance would have been an enormous undertaking even with modern equipment. The Inca managed it with ropes, levers, ramps, and human muscle power. They didn't have wheels, but they understood the principle of rolling logs and other friction-reducing techniques. They didn't have cranes, but they mastered the use of levers and counterweights. They didn't have draft animals suitable for construction work, but they had human ingenuity and organizational skill. The quarry also reveals something about the timeline of construction. The abandoned stones suggest that work here continued over a long period, possibly generations. Some stones show weathering patterns, indicating they were exposed to the elements for years before being used. Others appear to have been freshly worked when the quarry was abandoned, perhaps due to the arrival of the Spanish or some other disruption. This gives us a glimpse into the continuity of Inca construction. These weren't rushed projects completed in a single building season, but long-term investments that spanned generations. As you prepare to leave the quarry, you notice something that brings the human element back into focus. There are small dwellings and workshops near the quarry, simple structures that would have housed the stonemasons and their families. These weren't slaves worked to death. They were skilled craftsmen living near their workplace, passing their knowledge from one generation to the next. Children would have grown up watching their fathers and grandfathers work stone, learning the techniques through observation and gradual participation. This was a community as much as a workplace, and the walls in Cusco are as much a product of that community as they are of Inca engineering genius. The journey back to Cusco gives you time to reflect on everything you've seen. The stones in those impossible walls didn't just appear by magic. They were carefully selected, expertly extracted, precisely shaped, and laboriously transported by people whose names we don't even know. Every stone in every Inca wall represents hours, days, or even weeks of careful work by skilled craftsmen who understood their materials intimately and took pride in work that would outlast them by centuries. Back in Cusco, you find yourself in a small museum dedicated to Inca construction techniques. The displays are humble, but they hold the key to understanding how those impossible walls were created. What strikes you immediately is the simplicity of the tools. There's nothing here that looks sophisticated or high-tech. No complex machinery, no iron chisels, no mechanical devices that would be out of place in a medieval European workshop. And yet, with these basic implements, the Inca achieved results that modern architects still struggle to replicate. The most fundamental tool in the Inca stonemason's kit was the hammer stone, a simple river rock, harder than the stone being worked, used to chip away at the surface of the building material. These don't look like much, just rounded stones that fit comfortably in the hand, but they're the foundation of everything. The stonemason would strike the surface of the stone being worked, chipping away small fragments with each carefully aimed blow. Over hours, days, or weeks, the cumulative effect of thousands of precisely aimed strikes would transform a rough block into a perfectly shaped component. What's remarkable about this technique is that it requires an intuitive understanding of force, angle, and material properties. Each hammer strike must be hard enough to remove material, but not so hard that it cracks or damages the stone. The angle of impact determines whether the stone chips cleanly or shatters unpredictably. The Inca stonemasons had developed this understanding through centuries of accumulated knowledge passed down through generations of apprentices. They didn't have physics textbooks or material science laboratories, but they knew their stone intimately. The museum displays show various types of hammerstones, each suited to different purposes. Larger ones for rough shaping, smaller ones for finer work, differently shaped ones for reaching into corners or working specific angles. The stonemason would have a collection of these tools, each selected for the specific task at hand. It's not so different from a modern carpenter having different hammers for different jobs, except that the Inca stonemasons made their own tools from materials they found in riverbeds and quarry floors. Next to the hammerstones are examples of bronze and copper tools. The Inca did work with metal, but they didn't have iron smelting technology. Copper and bronze are softer than iron, which means they can't be used for hammering hard stone directly. They would deform or shatter. But they're excellent for finer work, for scraping, polishing, and precision shaping. The museum shows copper chisels, scrapers, and files that would have been used for the final stages of shaping, for creating the smooth surfaces and precise fits that characterize Inca walls. Bronze and copper tools could also be hardened through work hardening, repeatedly hammering the metal to change its crystalline structure, making it harder and more durable. The Inca understood this process perfectly well. The museum examples show tools that have clearly been work hardened, their edges shaped and maintained through careful use. These aren't crude implements, they're precision tools, lovingly made and meticulously maintained. One display shows what archaeologists believe were used as compasses or measuring instruments, simple devices made of wood or bone that would have allowed stonemasons to transfer shapes from one stone to another. If you're fitting stone A against stone B, you need to know exactly what shape each should have where they meet. These simple tools would have allowed stonemasons to map the interface between stones, ensuring perfect fits. They're elegant in their simplicity, effective without being complicated. Another section of the museum shows evidence of grinding and polishing stones. After a stone was roughly shaped with hammerstones and finally finished with bronze tools, the final step might have involved grinding it against another stone to achieve a perfectly smooth surface. This technique is still debated among archaeologists. Some believe it was commonly used, while others think it was reserved for special applications. Either way, the museum displays show stones that appear to have been ground or polished, their surfaces smoother than would be possible with hammering alone. Ropes and cords made from plant fibers are also displayed. These were essential for moving and positioning stones, and the museum shows examples of different weaves and thicknesses for different purposes. Thin cords for delicate work, thick ropes for moving massive blocks, specialized weaves for maximum strength or flexibility. The Inca were expert weavers, and they applied their textile expertise to create cords and ropes of incredible strength and durability. Some historical accounts suggest that Inca ropes were stronger than the European ropes of the time, capable of handling enormous weights without breaking. Wooden tools are also represented: levers, wedges, and simple implements that would have been crucial for moving and positioning stones. A properly placed lever can multiply human strength many times over, allowing a small group of people to move objects that would otherwise be impossible to budge. The museum shows various sizes and shapes of levers, each designed for specific applications. There are also wooden rollers, logs that could be placed under massive stones to reduce friction during transport. The Inca might not have had wheels, but they understood the principle of rolling. What you don't see in the museum is perhaps more revealing than what you do see. There are no iron tools, no steel chisels, no hard metals that would have made stone working dramatically easier. There are no mechanical devices like pulleys, though the Inca understood the principle of the lever. There's no clear evidence they used pulley systems for construction. There are no architectural plans or detailed drawings as far as we know. The Inca achieved their architectural marvels with surprisingly simple technology, relying on skill, patience, and accumulated knowledge rather than sophisticated tools. This simplicity is actually a key to understanding Inca's success. Their tools were made from materials that were readily available: river stones, plant fibers, wood, and relatively soft metals. They didn't depend on imported technologies or rare materials. If a hammerstone broke, another could be found in any riverbed. If a rope wore out, more plant fibers could be gathered and a new one woven. This technological self-sufficiency meant that Inca construction could continue uninterrupted even if trade routes were disrupted or resources became scarce. The simplicity of the tools also meant that knowledge was the critical component, not equipment. A modern construction project can be stalled by lack of specialized machinery or replacement parts. Inca construction depended on human expertise, which could be passed from one generation to the next regardless of material circumstances. The tools were simple enough that any skilled stonemason could make his own, ensuring that the knowledge could survive even if the physical tools didn't. As you leave the museum and return to the streets of Cusco, the impossible walls take on new meaning. You're no longer looking at mysterious miracles of unknown technology. You're looking at the product of generations of accumulated knowledge, of skilled craftsmen using simple tools with extraordinary precision. The achievement is perhaps more impressive knowing that it was accomplished with such basic technology, not because the Inca had secret knowledge unavailable to us, but because they developed an intuitive understanding of their materials and techniques that went beyond book learning into something deeper and more practical. The hammerstones and bronze tools in the museum may look simple, but they represent centuries of experimentation and refinement. Each improvement in technique, each slight increase in efficiency, each new understanding of how stone responds to different kinds of force, all of this was learned through trial and error, carefully remembered, and passed down to the next generation. The walls of Cusco aren't just examples of engineering skill, they're monuments to human perseverance and the power of accumulated knowledge. The museum has given you a theoretical understanding of the tools, but now you need to see how they were actually used. So you find yourself back at a construction site, this time not a finished wall, but a recreation that shows how Inca stonemasons might have worked. A group of modern craftsmen are demonstrating traditional techniques, using replicas of Inca tools to shape stones in the old way. What you're about to witness is something that few modern people have ever seen: the hammer and feather method in action. The principle is deceptively simple. A hard stone, usually river-worn and harder than the stone being worked, is used to chip away at the surface of the building stone. But this isn't random hammering. The stonemason is striking at very specific points, with very specific force, to remove very specific pieces of the stone. Each blow is calculated, precise, and directed toward a larger goal that exists only in the mason's mind. What you're watching is essentially stone sculpture in reverse. Instead of adding material to create a shape, the stonemason is removing material to reveal the shape that already exists within the block. But there's a crucial difference. The shape being revealed isn't chosen by the mason. It's determined by the requirements of the wall, how this particular stone needs to fit with its neighbors, what structural role it will play, what the overall aesthetic should be. The mason's skill lies in understanding those requirements and then removing exactly the right material to achieve them. The craftsman demonstrating the technique makes it look effortless, but you can tell it's anything but. Each hammer strike is preceded by a moment of careful observation. The mason studies the stone, examines how light plays across its surface, considers where the natural fractures and weaknesses lie. Only then does he raise the hammer stone and bring it down in a precisely controlled strike. A small chip flies off, and the stone is subtly altered. Then the process repeats. Observe, strike, observe again, strike again. What's remarkable is how little material is removed with each strike. We're talking about tiny fragments, barely visible to the casual observer. But over hours and days, these microscopic removals add up to significant changes in the stone's shape. This is the essence of the hammer and feather method. Extreme patience applied consistently over long periods. The Inca stonemasons didn't shape stones quickly. They shaped them inevitably. Given enough time and enough carefully directed hammer strikes, any shape is possible. The craftsman is working on creating a curved edge on his stone. You can see that he's not following a drawn line or template. Instead, he's working by eye and by feel, constantly checking the curve against some mental standard, adjusting his approach based on how each hammer strike affects the stone. Sometimes he strikes at the outer edge of the curve, sometimes closer to the center. Sometimes the blows are harder, sometimes softer. It's not random, there's clearly a method here, but it's a method that exists in the mason's muscle memory and intuition rather than in any external guide. What you're witnessing is the result of years of training and practice. The Inca stonemasons didn't learn their craft from books or blueprints. They learned through apprenticeship, watching skilled masters work, gradually participating under supervision, eventually developing the intuitive understanding that allows a mason to look at a rough stone and know exactly where to strike to achieve a desired effect. This kind of embodied knowledge can't easily be written down or explained. It has to be experienced and absorbed over time. The demonstration shows something else important: the relationship between the mason and the stone. This isn't a confrontational relationship where the mason tries to force the stone into submission. It's more collaborative. The mason is listening to the stone, paying attention to how it responds to each strike, adjusting his technique based on what the stone tells him. Sometimes the stone chips cleanly, revealing a smooth new surface. Sometimes it fractures unpredictably, revealing a hidden weakness or natural fault line. The mason adapts his approach accordingly, working with the stone's natural properties rather than against them. You notice that the craftsman is surprisingly relaxed. Stoneworking might sound like grueling physical labor, and there is certainly strength involved, but there's also a rhythm and a flow to the movements. The hammer stone moves in a controlled arc, each strike following the last with almost meditative consistency. This isn't frantic hammering. It's a steady, sustainable pace that could be maintained for hours. The Inca stonemasons would have needed to work like this day after day, year after year, without burning out or injuring themselves. Their technique was designed for endurance as much as for precision. The demonstration moves to a more advanced technique, creating a precise fit between two stones. The craftsman has two partially shaped stones and is working on making them fit together perfectly. He brings them together, examines where they contact and where gaps remain, separates them, and then returns to work with the hammer stone, selectively removing material from specific points. Then he tries the fit again, examining the contact points, and returns to more hammering. This back and forth process continues for what seems like an eternity. The craftsman is making incredibly small adjustments, removing tiny amounts of material with each cycle of testing and refining. But slowly, gradually, the fit improves. What started as two stones that touched at only a few points becomes stones that contact along larger surfaces. The gaps between them shrink and eventually disappear. Finally, the two stones are pressed together with perfect contact across their entire interface. No visible gaps, no uneven contact, just two stones that seem to have grown together rather than been assembled. What you've just witnessed is essentially the same technique that created those impossible walls in Cusco, writ small. The process would have been similar for the actual construction projects, except on a much larger scale and with many more stones. Each stone in an Inca wall was individually shaped to fit perfectly with its neighbors, using this same patient, iterative process of testing and refining. The difference is that a wall might have hundreds or thousands of stones. Each one individually fitted a project that could take decades to complete. The hammer and feather technique explains several characteristic features of Inca stonework. The smooth surfaces make sense. Each stone was repeatedly struck with hammer stones, gradually wearing down any roughness. The precise fits are exactly what you'd expect from this incremental approach, stone by stone. The masons work toward perfect contact. Even the interlocking shapes can be understood as a natural outcome of fitting each stone individually to its neighbors, rather than cutting them to predetermined dimensions. There's something almost meditative about watching this process. The craftsman is completely focused on his work, absorbed in the interaction between hammerstone and building stone. Each strike is a small moment of creation, a tiny step toward a goal that might be years away. The Inca stonemasons must have had this same ability to lose themselves in their work, to find satisfaction in the incremental progress of each hammer strike, to take joy in the slow transformation of rough stone into precise architecture. It's also worth noting what the hammer and feather method doesn't require. It doesn't require measurements or templates, though those might have been used for some purposes. It doesn't require complex tools or sophisticated technology. It doesn't require written plans or mathematical calculations. What it requires is an intuitive understanding of the material, excellent hand-eye coordination, enormous patience, and a clear vision of the final result. The Inca stonemasons had all of these in abundance. As you watch the craftsman continue his work, you realize that you're witnessing a form of knowledge that's largely lost to the modern world. We've replaced intuitive craftsmanship with standardized measurements and machine precision. We've forgotten how to work by feel and by judgment, how to develop the kind of embodied understanding that comes from years of hands-on experience. The Inca stonemasons weren't just skilled workers, they were masters of a craft that modern people can barely comprehend, let alone replicate. The demonstration finally ends, and the craftsman steps back to reveal the result. Two stones that fit together so perfectly that the seam between them is almost invisible. It's a small example of what you've seen in the walls throughout Cusco, but seeing the process makes the achievement even more impressive. Those impossible walls weren't created by magic or by lost technology. They were created by patient craftsmen using simple tools and techniques that had been refined over generations until they reached a level of sophistication that we're still struggling to understand today. You've seen how the stones were shaped, but that's only half the story. Now you need to understand how those massive blocks, some weighing as much as 200 tons, were moved from quarries miles away to construction sites high in the mountains. The Spanish chroniclers who first witnessed Inca architecture were baffled by this question, and modern engineers are still trying to figure out all the details. What we do know is that the Inca accomplished this feat without wheels, without draft animals suitable for heavy hauling, and without the mechanical advantage of pulleys. They did it with human muscle, clever engineering, and organizational genius. To understand how this was possible, you find yourself at another reconstruction site, this one focused on transportation techniques. A group of volunteers and archaeologists are experimenting with moving a moderately sized stone, perhaps 5 tons, using only Inca-appropriate technology. What you're watching is part of a long series of experiments aimed at understanding Inca transportation methods, and what you're seeing is both surprising and illuminating. The first thing you notice is that they're not trying to lift the stone. That would be impossible with human strength alone. Instead, they're using a combination of techniques to move the stone horizontally without ever having to support its full weight at once. The stone rests on a wooden sled, essentially a platform made of logs lashed together. The sled itself sits on a carefully prepared surface, a road bed that's been leveled and packed hard to minimize friction and prevent the sled from sinking into soft ground. You watch as the team prepares to move the stone. They've attached multiple ropes to the sled, each rope held by a group of workers. The ropes aren't pulling from a single direction. They're arranged at different angles to allow for steering and control. There are also side ropes that can be used for braking and directional adjustment. What's immediately clear is that this isn't just about applying maximum force, it's about controlled, coordinated movement. The team begins to pull, and to your surprise, the stone moves. It doesn't slide smoothly, there's a jerky, staccato quality to the movement. But with each coordinated pull, the sled advances a few inches, then settles. The team pauses, resets their grip, and pulls again. Over the course of minutes, they manage to move the stone several meters along the prepared road. It's slow going, but it's undeniably working. What you're witnessing is the power of friction reduction. The wooden sled slides over the carefully prepared road surface with significantly less resistance than the stone would have if dragged directly. The Inca understood this principle perfectly. Archaeological evidence suggests that they used various lubricants to further reduce friction. Water, wet clay, or even plant oils might have been used to create slippery surfaces that made heavy stones easier to move. The experiment then introduces another element: wooden rollers placed under the sled. This changes everything. Suddenly the stone moves much more smoothly, with dramatically less effort required from the pulling team. The rollers turn under the sled, effectively converting sliding friction into rolling friction. The Inca didn't have wheels in the sense of wheeled vehicles, but they certainly understood the principle of rolling and used it effectively for moving heavy objects. What's particularly clever about the roller technique is how the rollers are recycled. As the sled moves forward, rollers emerge from behind it. Workers quickly collect these and move them to the front, placing them back under the sled ahead of its path. This way, a relatively small number of rollers can be used repeatedly, allowing continuous movement. It's labor-intensive, but it works, and it's much more efficient than trying to slide a massive stone directly over the ground. The experiment demonstrates another crucial technique, using the terrain itself to assist in moving stones. The team has constructed a gentle incline leading up to where they want to place the stone. By building a ramp that gradually increases in elevation, they can use gravity to help position the stone precisely where it needs to go. The Inca were masters of this kind of gravitational engineering. They would build earthen ramps, sometimes extending for hundreds of meters, to gradually raise stones to the desired level. Once the stone was in place, the ramp material would be removed, leaving no trace of how it was accomplished. You also see demonstrations of leverage techniques. Using long wooden poles as levers, a small group of people can lift one corner of a massive stone, just enough to insert a shim or roller beneath it. Repeated carefully, this technique can gradually raise a stone to the desired height or shift it into a better position. The Inca understood the mechanical advantage of levers perfectly and used them extensively for fine adjustments during construction. What emerges from these demonstrations is a picture of accumulated knowledge applied cleverly to difficult problems. The Inca didn't have a single magic technique for moving massive stones. Instead, they had a toolkit of methods, sleds, rollers, ramps, levers, ropes, lubricants, each suited to different situations. A particular construction project might use all of these techniques in combination, applied based on the specific challenges of terrain, distance, and stone size. The flexibility and adaptability of their approach is what made it so effective. But there's another crucial element that these experiments can't fully capture: the human organization required. Moving a 200-ton stone isn't just about physics and engineering, it's about coordinating hundreds or thousands of workers in precise, synchronized effort. Someone had to plan the route, prepare the road surfaces, organize the pulling teams, coordinate the timing of everyone's efforts, and handle countless logistical details. The Spanish chroniclers noted that the Inca were extraordinarily well organized, and this organizational skill was probably just as important as any technical trick. Archaeologists have found evidence of the infrastructure that supported these transportation efforts. The Inca road system wasn't just for moving people and goods, it was also specifically engineered to facilitate the movement of construction materials. Roads were built wide enough to accommodate massive stones, with carefully prepared surfaces and gentle gradients that made heavy hauling feasible. Bridge constructions were designed to support enormous weights. Rest areas were established where workers could camp and resupply during long transport operations. The human cost of all this effort must have been enormous, though not in the way you might assume. The Inca system of mita reciprocal labor meant that people contributed work on public projects as part of their civic duty. This wasn't slave labor. Workers were fed and housed during their service, and the state provided reciprocal benefits in the form of redistribution and protection. But the work was undoubtedly grueling, and the physical demands on the workers were extreme. Spanish accounts describe Inca laborers as incredibly strong and accustomed to hardship, capable of feats of endurance that shocked European observers. What's particularly remarkable is that the Inca continued to use these labor-intensive methods even after they had the opportunity to adopt European technologies. When the Spanish arrived with horses, oxen, and wheeled carts, the Inca apparently didn't see these as superior alternatives for their construction projects. They continued using their traditional methods, suggesting that those methods were actually more effective for their specific circumstances and needs. The Inca weren't primitive, they had simply developed different solutions to different problems, and those solutions worked remarkably well. As you watch the experimental team continue their work, you realize that you're gaining a new appreciation for those massive stones in the Inca walls. Each one represents not just technical skill but logistical triumphs. The coordinated effort of hundreds of people moving heavy objects over difficult terrain using clever techniques and accumulated knowledge. The walls are monuments not just to engineering skill but to human cooperation and the ability to organize complex collective action toward distant goals. You're also struck by the patience required. Everything about Inca construction was slow. Stones weren't moved quickly, they were moved inevitably, through sustained effort applied consistently over long periods. A construction project might span generations, with workers knowing that they might not live to see the final result, but continuing nonetheless, because they understood themselves as part of something larger than any individual life. This kind of long-term thinking is almost unknown in the modern world, and it helps explain how the Inca achieved results that we still struggle to comprehend. The demonstration of transportation techniques has been impressive, but now you're about to see something that explains another key to Inca success: the practice of trial fitting stones on the ground before incorporating them into the actual wall. This is a technique that archaeologists have inferred from evidence at Inca construction sites, and seeing it demonstrated makes everything click into place. The reconstructed work area shows a flat, open space where multiple stones are laid out on the ground. These aren't just random stones, they've been arranged in a pattern that clearly mimics a section of wall, but laid horizontally rather than vertically. Craftspeople are moving among them, examining fits, making adjustments, and gradually refining the arrangement. What you're seeing is essentially a wall built on the ground, a practice assembly that allows for easy modification before the final construction begins. The advantages of this approach become immediately obvious. Working on the ground is much easier than working at height. Stones can be positioned and repositioned without the complications of gravity or the danger of collapse. Access is unrestricted. Craftsmen can examine the fit between stones from any angle, make adjustments freely, and take their time to get everything perfect before moving to the next phase. It's essentially a design process happening in real time, with the actual building materials rather than abstract plans. What you're watching is a team working on fitting 3 stones together in a specific pattern. They've already done preliminary shaping at the quarry, but the final fitting happens here, on the ground. They bring the stones together, examine where they contact, identify gaps or misalignments, and then use hammer stones to make tiny adjustments. The process is iterative: fit, examine, adjust, fit again, repeated until the 3 stones lock together perfectly. You notice something important. They're not just checking where 2 stones meet, they're considering how all 3 stones interact as a unit. An adjustment that improves the fit between stones A and B might throw off the fit between stone B and stone C. The craftsmen have to think in 3 dimensions, considering multiple interfaces simultaneously. It's a complex puzzle, and the solution isn't just getting individual pairs to fit, it's achieving perfect contact throughout the entire assembly. Once the 3 stones are fitted together perfectly, the team marks their positions relative to each other. You see them using paint or chalk to create matching marks on adjacent stone symbols that will allow them to reassemble the stones in exactly the same configuration later when they're being incorporated into the actual wall. These marks are crucial. Without them, it would be nearly impossible to remember exactly how the stones were fitted, especially when dealing with complex interlocking shapes. The demonstration then shows the next step: disassembling the fitted group and preparing it for vertical installation. The stones are carefully separated, their marked interfaces noted, and then moved one by one to the actual wall under construction. What was just a dry run on flat ground now becomes the real thing, but with the confidence that comes from knowing the stones will fit perfectly when installed. This practice of trial fitting explains several characteristic features of Inca walls. First, it accounts for the incredible precision of the fit. Stonemasons could work slowly and methodically on the ground, making incremental adjustments until perfection was achieved, without the pressures and complications of working at height. Second, it explains the complex interlocking shapes. These weren't just aesthetic choices, but structural necessities that emerged from the process of fitting multiple stones together on the ground and then reproducing that fit in the vertical wall. What's particularly clever about this technique is how it reduces risk. Wall construction is inherently dangerous. Stones are heavy, heights are significant, and mistakes can be catastrophic. By doing as much work as possible on the ground, the Inca minimized the time spent working at height and reduced the chances of something going wrong during final installation. The actual wall raising became a known quantity with predictable outcomes rather than an experiment conducted in real time. The trial fitting process also allowed for quality control. Before a stone was permanently installed in a wall, its fit could be thoroughly examined and verified. If there were problems, they could be addressed on the ground where modifications were easier. This meant that the final wall was essentially a pre-assembled kit, each piece tested and verified before being locked into its permanent position. It's not so different from how modern manufacturing works, except that the Inca were doing this centuries before industrialization. You notice that the demonstration team is working on a relatively small assembly, 3 or 4 stones fitted together, but you can easily imagine how this would scale up. An entire wall section could be assembled on the ground, piece by piece, each stone carefully fitted and marked. Then the entire assembly could be disassembled and reconstructed in its permanent vertical location. The result would be a wall where every single interface had been perfected under optimal conditions before final installation. This technique also helps explain another mystery: how the Inca managed to create walls where stones interlock from multiple directions. In many Inca walls, each stone is fitted not just to the stones immediately adjacent to it, but also to stones further away in the assembly. This 3-dimensional interlocking would be incredibly difficult to achieve while building vertically. But if the entire section was assembled on the ground first, where the entire pattern could be laid out and examined as a whole, then these complex interlocking fits become much more understandable. The demonstration shows another aspect of this technique: the use of reference stones. The team has placed a few marker stones that establish the overall dimensions and orientation of the wall section. All other stones are fitted relative to these reference points, ensuring that the final wall will have the desired shape and alignment. This is essentially a form of construction by reference. Instead of following detailed plans, the builders work from a few key positions and fit everything else to those anchors. What's particularly elegant about this approach is how it combines flexibility with precision. The Inca weren't locked into rigid, predetermined dimensions for every stone. They could adjust and adapt based on the specific characteristics of each stone and how it responded to shaping. But by using reference points and trial fitting, they could still ensure that the final assembly had exactly the shape and size they wanted. It's the best of both worlds: adaptive craftsmanship within a precise framework. The practice of trial fitting on the ground also explains why Inca walls have such a natural, organic quality. The stones weren't cut to identical sizes and shapes. Each one was treated as an individual, with its own character and peculiarities. The overall pattern emerged from the process of fitting unique individuals together, rather than forcing everything into a predetermined grid. The result is a wall that feels almost alive, a community of stones that have grown together, rather than a manufactured construction. As the demonstration team finishes fitting another group of stones and begins marking them for installation, you find yourself marveling at the combination of simplicity and sophistication. The basic idea, fitting stones together on the ground before installing them, is straightforward enough. But the execution requires enormous skill, experience, and judgment. The Inca stonemasons had to visualize in 3 dimensions, think through how each adjustment would affect multiple interfaces, and maintain a clear picture of the final assembly even while working on individual components. This technique also represents a significant time investment. Each stone might be fitted and refitted multiple times before being permanently installed. The process of trial fitting, marking, disassembling, and then reassembling in the final location added considerable time to the construction process. But this investment paid off in the quality and durability of the finished walls. The Inca understood that it was better to spend extra time during construction than to deal with structural problems later. They were building for centuries, not for quick completion, and their techniques reflect that long-term perspective. Everything you've seen so far has been well documented and relatively non-controversial. Hammer stones, bronze tools, trial fitting, these are techniques that archaeologists generally agree were used by the Inca. But now you're about to encounter something more mysterious. The grinding technique, a method that's still debated among experts, and that some believe explains the most impossible aspects of Inca stonework. The theory goes like this. In addition to hammering and chipping away at stones, the Inca might have used a grinding technique where 2 stones were rubbed against each other to achieve perfect fits. This would explain the incredibly smooth interfaces between some stones, where the contact surfaces are almost polished rather than simply shaped. It would also account for fits so precise that no gap is visible even under close examination, something that's difficult to achieve through hammering alone. You're at an archaeological site where evidence of this technique might have been found. The guide points out a feature that's easy to miss. Flat, polished surfaces on some stones that don't appear to serve any structural purpose. These surfaces aren't part of wall interfaces or visible faces. Instead, they seem to be areas where stones were deliberately smoothed and flattened, perhaps as part of a grinding process. The theory is that 2 stones could be ground against each other by placing them in contact and then moving them back and forth, possibly with an abrasive material like sand or wet clay between them. Over time, this grinding action would wear away both surfaces, gradually bringing them into perfect conformity with each other. It's similar in principle to how 2 rough objects can be smoothed by rubbing them together, like using 2 pieces of sandpaper to smooth each other. What makes this technique so intriguing is that it would create a custom fit that's essentially perfect at the microscopic level. When you grind 2 surfaces against each other, high spots on each surface wear away faster than low spots, naturally creating a perfect contact pattern. It's a process that happens almost automatically, without requiring precise measurements or careful targeting of specific areas. The stones essentially shape themselves to each other through the grinding action. The guide shows you experimental evidence that supports this theory. Archaeologists have attempted to replicate the technique using simple materials and methods that would have been available to the Inca. Using 2 rough stones, sand, and human labor to move the stones against each other, they were able to achieve fits that are remarkably similar to what's seen in Inca walls. The process is slow, painfully slow, but the results are undeniable. You're also shown evidence from Inca sites themselves. Some stones have what appear to be wear patterns consistent with grinding parallel striations that suggest repeated back and forth motion. Other stones have perfectly flat surfaces that seem too smooth to have been achieved through hammering alone. None of this proves that grinding was widely used, but it certainly suggests that the technique was at least part of the Inca stonemason's toolkit. What's particularly interesting about the grinding theory is how it relates to the Inca worldview we discussed earlier. If stone is seen as a living entity rather than inert material, then grinding two stones together takes on a different meaning. It's not just a mechanical process, it's a way of helping two stones get to know each other, of allowing them to find their natural fit through interaction, rather than forcing them into a predetermined shape. The stones are literally working on each other, with human assistance but according to their own properties and tendencies. However, not all archaeologists are convinced. Critics of the grinding theory point out several problems. First, the technique would be extraordinarily time-consuming, far more so than hammering alone. Grinding two multi-ton stones against each other would require enormous effort, and it's not clear that the results would be sufficiently better to justify the additional work. Second, there's limited direct evidence. While some stones show possible grinding marks, these could also be explained by other techniques. Third, the technique would be difficult to apply in many situations. How do you grind stones that are already part of a wall, for example? The debate continues, but what's clear is that the Inca used multiple techniques in combination. Hammering was certainly important for rough shaping. Chisels and other bronze tools were used for finer work. Grinding might have been used for specific applications where perfect fits were especially important. The Inca weren't committed to a single method. They used whatever approach worked best for the particular situation, combining techniques as needed to achieve their goals. What's also clear is that we may never fully understand all the techniques the Inca used. Much of the knowledge was passed down orally and practically, from master to apprentice, through hands-on experience rather than written documentation. When the Spanish arrived and disrupted Inca society, much of this specialized knowledge was lost. We're left trying to reverse engineer techniques from the finished results, which is like trying to reconstruct a recipe just from tasting the final dish. You're also shown evidence of another controversial technique, the use of plant-based chemicals to soften or shape stone. Some researchers have identified plants in the Andes that can soften certain types of stone when applied as a juice or paste. The theory is that Inca stonemasons might have used these plant materials to make stone more workable, essentially a chemical approach to stone shaping that complemented their mechanical techniques. This theory is even more controversial than the grinding technique. Mainstream archaeology remains skeptical, pointing out that there's no direct historical evidence of such techniques being used, and that the effects of plant-based stone softening are limited and specific. But the fact that serious researchers are even considering these possibilities tells you how mysterious Inca stonework remains. We're still trying to understand techniques that might have been lost for centuries, knowledge that existed only in the minds and hands of Inca craftsmen. What emerges from all of this is a picture of sophisticated, adaptable craftsmanship. The Inca stonemasons weren't following a simple recipe or using a single technique. They had a range of methods at their disposal, each suited to different situations and materials. They understood their tools and materials intimately, and they could combine techniques in ways that we're still trying to figure out. Their work represents the pinnacle of a long tradition of Andean stoneworking, knowledge accumulated over centuries and refined to an extraordinary degree of sophistication. As you leave the grinding demonstration site, you find yourself reflecting on how much we may never know about Inca construction techniques. The walls themselves are undeniable evidence of extraordinary skill and knowledge, but the specific methods used to create them remain partly mysterious, lost to history along with the craftsmen who developed and perfected them. What we can say for certain is that the Inca achieved results that still impress and puzzle us today, using a combination of known techniques and possibly some that have been lost forever. The uncertainty is frustrating in some ways. We want clear answers, definitive explanations, But there's also something beautiful about not fully understanding. Those impossible walls retain a touch of mystery, a sense that the Inca knew things we don't, developed techniques we can barely imagine. They remind us that knowledge can take many forms, not all of which can be easily documented or passed down. Some knowledge exists only in practice, in the hands and minds of skilled practitioners, and when that lineage is broken, the knowledge is gone, even if the products remain. You've seen the techniques and the tools, but now it's time to see them applied on the grandest scale. You're ascending the hill above Cusco to Sacsayhuaman, the fortress that represents perhaps the most extraordinary example of Inca stonework anywhere. What you're about to see will make everything you've witnessed so far seem small by comparison. As you climb, the massive zigzag walls of Sacsayhuaman come into view. From a distance, they're impressive enough, 3 parallel walls stretching across the hilltop, their distinctive zigzag pattern clearly visible. But it's only as you get closer that the true scale becomes apparent. These aren't just big walls, they're built with stones so enormous that they defy comprehension. The largest stones at Sacsayhuaman weigh an estimated 200 tons each, roughly the equivalent of 200 cars or 3 adult blue whales, and they were moved, shaped, and fitted together with the same precision you've seen in the smaller walls of Cusco. You approach the first wall and stop, unable to continue without taking a moment to absorb what you're seeing. The stones here are so large that you can't even see the tops of them from close up. You have to walk back just to get a complete stone in your field of vision. The smallest stones in these walls are the size of a large car. The largest are bigger than a house, and every single one of them is fitted with the same impossible precision you've seen elsewhere. No gaps, no mortar, just perfect contact between irregular shapes that somehow interlock like pieces of a 3-dimensional puzzle. What makes Sacsayhuaman particularly mind-boggling is that these enormous stones weren't just placed in flat, easily accessible locations. They're part of walls that follow the natural contours of the hill, rising and falling with the terrain. Some stones are positioned at significant heights, requiring not just horizontal transport but vertical positioning. The logistics involved in moving 200-ton stones up a hill and then installing them in a wall are almost impossible to visualize. You walk along the base of the wall, looking up at stones that seem to defy gravity. How did they lift these massive blocks into place? There are no crane marks, no evidence of lifting equipment that could handle such weights. The best current theory involves using earthen ramps, temporary structures built against the wall, allowing stones to be gradually raised into position. Once the stone was in place, the ramp material would be removed, leaving no trace of how it was accomplished. But ramps only solve part of the problem. Even with ramps, you still need to get the stone up the ramp. The Spanish chroniclers recorded that the Inca used enormous ropes made from plant fibers, along with human labor organized in highly coordinated teams. Thousands of workers might have been required for the largest stones, pulling in unison while others guided the stone and managed the ropes. It would have been a massive organizational undertaking, requiring precisely coordinated effort and impeccable timing. You notice something else about these massive stones. They're not all the same size or shape. Some are roughly rectangular, others are more irregular. They fit together in complex interlocking patterns where each stone supports and is supported by its neighbors. This interlocking isn't just about structural stability, though it certainly provides that. It's also about working with the natural shapes and properties of the stones, minimizing the amount of shaping required while still achieving perfect fits. The lower levels of the walls use the largest stones, with stones gradually becoming smaller in higher levels. This makes structural sense. Massive stones at the base provide a solid foundation, while smaller stones higher up are easier to position at height. But it also suggests a construction process where the largest and most challenging stones were placed first, using the stability of the ground for support, and then smaller stones were added progressively upward. You find yourself standing before one particularly enormous stone, so large that you could comfortably build a small house on top of it. The surface is smooth and regular, shaped with the same care and precision as much smaller stones. You can see the hammer marks, the signs of patient shaping with stone tools, but what you can't see is how many person-hours went into this single stone, how many stonemasons worked on it, how many weeks or months did it take to shape, how many people were required to move it into position. The scale of Sacsayhuaman suggests that it wasn't built quickly or by a small workforce. Archaeologists estimate that the construction might have taken decades, involving thousands of workers over multiple generations. The Inca approach to major construction projects was essentially the same as their approach to stonemasonry in general: slow, patient, inevitable progress toward a distant goal. They weren't in a hurry. They were building for eternity. What's particularly striking about Sacsayhuaman is how it combines massive scale with exquisite attention to detail. The enormous stones might seem to demand rough, expedient construction methods, but instead, even the largest stones show evidence of careful shaping and finishing. The Inca didn't sacrifice quality for scale. They maintained their exacting standards, regardless of stone size or logistical difficulty. Every stone in these walls, from the smallest to the largest, was treated with the same care and respect. You climb to a higher vantage point and look down on the fortress complex. From here, you can see the full extent of the construction: the 3 zigzag walls, the towers and platforms, the intricate system of terraces and staircases. The overall design is clearly military in nature: defensive walls protecting the northern approach to Cusco, with excellent views of the surrounding valleys. But the military function is expressed through architecture of extraordinary sophistication and beauty. The zigzag pattern of the walls has been the subject of much speculation. Some scholars see it as representing the teeth of a puma, since Cusco itself was laid out in the shape of a puma. Others see practical military considerations, the zigzag design providing multiple angles of defense and making it difficult for attackers to find shelter along the walls. Still others see astronomical or religious significance in the pattern. The truth probably involves multiple layers of meaning, with the design serving military, symbolic, and ceremonial functions simultaneously. From your elevated position, you can also see how the fortress integrates with the surrounding landscape. The walls follow the natural contours of the hill rather than imposing an artificial shape on the terrain. The stones are local, extracted from nearby quarries. The overall effect is of a structure that grows out of the mountain rather than being placed on top of it. This integration with landscape is characteristic of Inca architecture and reflects their worldview, in which human construction and natural formation were part of a continuum rather than opposed categories. What you're looking at was effectively destroyed by the Spanish after their conquest of Cusco. They recognized the military value of Sacsayhuaman and didn't want it being used against them, so they dismantled much of the complex. The 3 zigzag walls you see today are only a fraction of the original construction. Towers, buildings, and additional defensive works have all disappeared, their stones reused in Spanish colonial buildings throughout Cusco. What remains is impressive enough. It's almost impossible to imagine what the complete complex must have looked like. The Spanish also attempted to destroy the largest stones, breaking them apart with iron wedges and fire. They mostly failed. The stones were too hard, their fit too perfect. Even with superior technology, the conquistadors couldn't completely dismantle what the Inca had built. There's something poetic about this, a sense that the Inca construction was so fundamentally sound that even destructive effort couldn't fully undo it. The walls of Sacsayhuaman have withstood not just time and earthquakes, but deliberate attempts to destroy them. As you prepare to leave Sacsayhuaman, you find yourself reflecting on what this place represents. It's not just an architectural marvel or an engineering feat. It's a testament to what humans can accomplish with determination, organization, and skill. The Inca didn't have superior technology in many ways. Their tools and techniques were simpler than what other civilizations had developed, but they applied what they had with extraordinary effectiveness, achieving results that continue to amaze us 5 centuries later. Sacsayhuaman also represents the cumulative nature of Inca knowledge. The techniques used here didn't appear overnight. They were developed over centuries, building on earlier Andean traditions, refined through countless experiments and improvements. Each generation of stonemasons added to the knowledge they inherited, passing an expanded and improved toolkit to the next generation. By the time Sacsayhuaman was built, the Inca had mastered stone construction to a degree that has perhaps never been equaled since. What you've seen today, both the smaller scale work in Cusco and the massive constructions here at Sacsayhuaman, represents the pinnacle of a long tradition. The Inca didn't invent Andean stonework, but they perfected it. They took techniques that had been developing for thousands of years and brought them to their highest expression. The result is architecture that continues to inspire awe and speculation, a reminder that knowledge can take many forms and that different civilizations can solve similar problems in very different but equally sophisticated ways. After the overwhelming scale of Sacsayhuaman, you return to Cusco to examine something you've noticed throughout your journey but haven't fully explored yet: the characteristic polygonal style of Inca walls. You're sitting in a quiet plaza, staring at a wall where the stones form complex interlocking patterns, and you realize that this distinctive style isn't just aesthetic, it's a profound expression of Inca engineering philosophy. The term polygonal refers to the multi-sided, irregular shapes of the stones. Unlike rectangular bricks or cut stones that fit together in simple grid patterns, these stones have many sides, each shaped to fit perfectly against its neighbors. The result is a wall where stones don't just sit next to each other, but actively hold each other in place through their shapes. It's like a 3-dimensional puzzle where each piece is locked into its neighbors from multiple directions. What's particularly clever about this approach is how it distributes stress throughout the wall. In a traditional rectangular wall, stress is primarily transferred vertically from one stone to the stone below it. Horizontal stress transfer is limited unless mortar is used effectively. But in a polygonal wall, stress can be transferred in multiple directions because each stone is in contact with several neighbors from different angles. This creates a structure that's incredibly stable and resistant to various kinds of forces. You notice that the polygonal style isn't uniform. Different walls use different approaches. Some stones are only slightly irregular, with just enough variation to create the characteristic interlocking effect. Others are dramatically angular, with complex shapes that seem almost organic in their irregularity. This variation suggests that the Inca weren't following a rigid template, but were adapting their techniques to specific situations and materials. The polygonal style also has practical advantages beyond structural stability. Because each stone is individually shaped to fit its neighbors, the Inca could use stones that wouldn't be suitable for rectangular construction. Irregularly shaped stones from the quarry could be incorporated as is, with minimal shaping, simply by fitting them into appropriate positions in the wall. This reduced waste and made more efficient use of available materials. It also meant that each stone could be treated as an individual rather than being forced into a standardized mold. What you're looking at also has implications for how the walls were constructed. With rectangular stones, construction follows a relatively straightforward pattern: lay one course, then the next, building upwards systematically. But with polygonal stones, the construction process would have been more complex. Stones couldn't simply be stacked in courses. Each stone had to be fitted to multiple neighbors simultaneously. This required a more flexible, iterative approach, where stones were added, adjusted, and sometimes removed and replaced as the wall took shape. You remember the trial fitting technique you saw demonstrated earlier, and now you understand how essential it would have been for polygonal construction. Fitting irregular stones together in complex three-dimensional patterns is difficult enough on the ground. Doing it at height, while building vertically, would be extraordinarily challenging. By assembling sections on the ground first, where the entire pattern could be laid out and refined, the Inca could achieve the precision of polygonal fits without the complications of working at height. The polygonal style also relates to the Inca philosophy of working with stone rather than dominating it. Rectangular construction requires imposing a regular pattern on irregular materials. Polygonal construction allows the natural characteristics of each stone to guide the process. Some stones are long and narrow, others are more compact. Some have angles that suggest specific orientations. The polygonal style accommodates all of these variations, turning potential problems into design features. What's particularly interesting about polygonal masonry is that it's not unique to the Inca. Similar techniques have been used in various cultures around the world, from ancient Greece to medieval Japan, but the Inca version is distinctive in its scale and precision. What other cultures did on a small scale, with carefully selected stones, the Inca did on a massive scale with stones of all sizes and shapes. Their polygonal walls aren't just examples of this technique, they're its supreme expression. You examine a section of wall where the polygonal style is particularly pronounced. The stones vary dramatically in size, from small blocks that you could lift yourself to massive stones that would require many people to move. Yet they all fit together in the same complex pattern, creating a unified whole. This is one of the most remarkable aspects of Inca stonework, the way it accommodates extreme variation while maintaining overall harmony. Every stone is unique, yet all contribute to a single coherent structure. The polygonal style also has implications for the construction process. Because each stone is individually fitted, the walls don't have distinct horizontal courses. Instead, the pattern of joints between stones is irregular and three-dimensional. This means that construction couldn't simply proceed one layer at a time. Stones might be added at various heights as the wall took shape, with the overall pattern emerging gradually rather than being predetermined. This required a different kind of planning and foresight, more like painting a picture than stacking boxes. What you're appreciating now is that the polygonal style isn't just a building technique, it's a way of thinking. It reflects a worldview that values individuality within community, that sees strength in diversity rather than uniformity. Each stone is unique and retains its individual character, yet all work together to create something stronger than any individual stone could be alone. It's hard not to see this as a metaphor for Inca society itself, where diverse peoples and traditions were incorporated into a unified empire. The aesthetic qualities of the polygonal style are also worth appreciating. There's a visual complexity and interest that rectangular walls lack. The play of light across the irregular surfaces creates subtle shadows and highlights that change throughout the day. The variation in stone shapes gives the wall a dynamic, almost organic quality, as if it's a living thing rather than a static construction. This aesthetic dimension wasn't accidental. The Inca clearly cared about beauty as well as function, and their techniques serve both purposes simultaneously. As you continue studying the wall, you notice another characteristic feature: the way the polygonal pattern changes across different sections of the wall. In some areas, the stones are only slightly irregular, creating a subtle polygonal effect. In other areas, the stones are dramatically angular, creating complex interlocking patterns. This variation suggests that the Inca adapted their techniques based on structural requirements, available materials, and possibly aesthetic preferences. They weren't locked into a single approach, but could vary the polygonal style based on circumstances. The polygonal style also has interesting implications for how the walls have aged over time. Because stress is distributed throughout the structure rather than being concentrated at specific weak points, these walls have been incredibly resistant to weathering and seismic activity. When earthquakes shake the region, the walls move and shift slightly, but generally settle back into their original configuration rather than collapsing. The interlocking nature of the stones means there's no straight path for cracks to follow, and the distributed stress prevents any single point from being overloaded. What you're looking at is essentially a self-reinforcing structure. As the wall experiences stress from its own weight, or from external forces like earthquakes, the interlocking stones actually become more tightly pressed together, increasing friction and making the structure more stable. It's a brilliant application of the principle that pressure can increase stability, like how a stack of irregular pebbles can become more stable when compressed from above. You find yourself marveling at the intuitive understanding of physics and engineering that the polygonal style represents. The Inca didn't have textbooks on structural mechanics or computer models for stress distribution. They had accumulated knowledge passed down through generations, combined with careful observation of what worked and what didn't. Their understanding of how forces work in structures was embodied rather than abstract, expressed in the techniques they used and the walls they built, rather than in written formulas or diagrams. This embodied understanding is perhaps the most difficult aspect of Inca architecture for modern people to grasp. We're used to knowledge that can be written down, standardized, and easily transmitted. The Inca had knowledge that existed primarily in practice, in the hands and eyes of skilled craftsmen, transmitted through apprenticeship and experience, rather than through books or formal instruction. The polygonal walls are the physical manifestation of this kind of knowledge, beautiful, sophisticated, and almost impossible to fully understand from the outside. You're sitting in a small cafe in Cusco, sipping a traditional corn drink, when suddenly you feel it a subtle shaking, a gentle rolling motion that makes the table tremble and the hanging lamp sway. It's an earthquake, mild by Peruvian standards, but enough to be felt. What happens next is something that Spanish chroniclers recorded with amazement centuries ago, and what you're about to witness firsthand. The Spanish colonial building across the street, with its rectangular brick construction and mortar joints, begins to creak ominously. You can see small cracks forming in the plaster, dust falling from where the walls meet the ceiling. The building sways and groans, clearly stressed by the seismic movement. But right next to it, An Inca wall, part of the original foundation that the colonial building was constructed on, barely seems to notice. The stones shift slightly, almost imperceptibly, dancing to the earthquake's rhythm. Then, as the shaking stops, they settle back into exactly their original positions, as if nothing had happened. This is the famous earthquake dance of Inca walls, and you've just witnessed it in real time. The Spanish were so astonished by this phenomenon that they wrote detailed accounts of it. How could structures built without mortar 5 centuries earlier outperform the most modern European construction techniques? The answer lies in the very features you've been learning about: the polygonal stone shapes, the absence of mortar, the precise fits, and the distributed stress patterns. To understand why Inca walls are so earthquake resistant, you need to understand how earthquakes affect buildings. The primary damage from earthquakes comes from ground movement, causing buildings to shake, sway, and deform. Traditional buildings with rigid connections and mortar joints develop stress concentrations at weak points, usually the mortar lines between bricks or stones. When these weak points fail, cracks propagate through the structure, eventually leading to collapse. Inca walls avoid this problem through several design features. First, the absence of mortar means there are no weak joints where cracks can initiate. Each stone is in direct contact with its neighbors, and the friction between these carefully fitted surfaces is what holds the wall together rather than brittle mortar that can crack. Second, the irregular polygonal shapes mean there are no straight continuous seams through the wall. Even if a crack were to develop, it would quickly be deflected by the irregular stone shapes and couldn't propagate far. Third, the interlocking nature of the stones means that when the wall shakes, the stones move slightly relative to each other, dissipating energy rather than accumulating stress. It's a bit like how a suspension bridge flexes in the wind rather than remaining rigid and potentially breaking. This flexibility allows Inca walls to ride out earthquakes that would destroy more rigid structures. Fourth, the distributed stress patterns mean that no single point in the wall is bearing a disproportionate load. When the ground moves, stress is redistributed throughout the structure rather than being concentrated at weak points. What you witnessed during the earthquake was this flexibility in action. The Inca wall didn't remain rigid, it moved, shifted, and adjusted to the ground motion, but its movement was constrained by the interlocking stone shapes, preventing any displacement large enough to cause failure. Once the shaking stopped, the stones settled back into their original configuration, held in place by gravity and friction. The wall effectively absorbed the earthquake's energy and then returned to its stable state. The Spanish buildings, by contrast, are more rigid. Their mortar joints are designed to be rigid connections between bricks or stones, and when the building shakes, these rigid connections fail. Cracks develop at weak points and propagate through the structure, potentially leading to catastrophic failure. Even if the building doesn't collapse, it sustains damage that requires repair. The Inca wall, by contrast, generally requires no repair after an earthquake. It simply returns to its original state. You might wonder why, given the obvious superiority of Inca construction techniques in seismic zones, the Spanish didn't adopt these methods. The answer is complex. Partly, it was a matter of cultural arrogance. The Spanish saw their own architectural traditions as superior and didn't recognize the sophistication of Inca techniques. Partly, it was a matter of different priorities. Spanish construction methods were faster and required less specialized skill, even if they were less suitable for local conditions. And partly, It was a matter of knowledge transfer. The Inca building techniques were based on centuries of accumulated knowledge that couldn't be quickly learned or adapted by outsiders. What's particularly interesting is that modern earthquake-resistant engineering has, in some ways, come full circle back to Inca principles. Contemporary seismic design emphasizes flexibility and energy dissipation rather than rigidity. Modern buildings in earthquake zones are designed to move with the ground rather than resisting it, using flexible connections and energy-absorbing elements that aren't so different from the interlocking stones of Inca walls. The Inca didn't have our physics or engineering knowledge, but they understood the principles through accumulated experience. You're also struck by the context dependence of all of this. Inca construction techniques are perfectly adapted to the seismic conditions of the Andes. In a non-seismic zone, some of these features might be unnecessary overkill, but in a region where earthquakes are a regular occurrence, the extra effort required for polygonal masonry and precise stone fitting pays off in structures that can survive for centuries with minimal maintenance. The Inca weren't showing off or being gratuitously elaborate. They were solving specific problems with specific solutions, even if those solutions required enormous effort. What you're appreciating now is the deep time scale over which Inca construction techniques evolved. The Andes have been seismically active for millions of years, and the peoples who have lived there have been developing earthquake-resistant architecture for millennia. The Inca inherited and refined this long tradition, building on knowledge that had been accumulated through countless earthquakes and structural experiments. Each generation learned from the failures and successes of the past, gradually developing techniques that were exquisitely adapted to local conditions. You leave the cafe and walk through the streets of Cusco, looking at the surviving Inca walls with new appreciation. These aren't just beautiful structures, they're solutions to a difficult engineering problem that have withstood the test of time and nature. Every time an earthquake shakes Cusco, these walls demonstrate their superiority to more recent construction methods. The Spanish may have conquered the Inca politically, but in this architectural arena, the Inca continue to win 5 centuries later. The earthquake resistance of Inca walls also highlights something fundamental about the difference between traditional and modern knowledge systems. Modern engineering tends to be explicit and theoretical. We can calculate stress distributions, model seismic forces, and predict how structures will respond. Traditional knowledge is often implicit and practical. It can't always be explained in formulas or diagrams, but it's been tested through real-world experience over long time scales. Neither approach is inherently superior. They're different ways of knowing, each with its own strengths and limitations. What you're witnessing is traditional knowledge at its finest, refined through generations of observation and experimentation, perfectly adapted to specific local conditions, and expressed through techniques that are both beautiful and functional. The Inca walls aren't just examples of engineering skill. They're monuments to a way of knowing that modern people have largely lost, where knowledge is embodied, practical, and tested against the unforgiving criteria of real-world performance. As the sun sets over Cusco, painting the sky in shades of gold and purple, you find yourself feeling grateful that these walls have survived. They're not just architectural marvels, they're teachers, offering lessons in engineering, in patience, in the value of accumulated knowledge, and they're reminders that different civilizations can solve similar problems in very different but equally sophisticated ways. The Inca solution to the challenge of building in a seismic zone may not be our solution, but it works. It has worked for centuries, and it continues to work today. That's a kind of validation that no theory or calculation can provide. After witnessing the earthquake dance of Inca walls, you make your way to what was once the most sacred site in the Inca Empire, Coricancha, the Temple of the Sunday. The Spanish destroyed much of the original temple and built the Church of Santo Domingo on top of its foundations, but enough remains to give you a glimpse of its former glory. What you're about to see represents the pinnacle of Inca stonework craftsmanship, so fine that it was reserved for the most sacred spaces. You enter the complex and immediately notice a dramatic difference in the stonework. The walls here are built with stones that are smaller and more regular than what you've seen in other Inca constructions. But what's truly remarkable is the precision of the fits. These aren't just tight joints, they're virtually invisible. The stones are shaped so perfectly that you often can't find the seam even when you're looking for it. The surfaces are smoothed to a polish that makes the walls look almost like they were carved from single pieces of stone rather than assembled from many blocks. This is the finest Inca stonework you've seen, and according to historical accounts, it represents the highest level of craftsmanship that Inca stonemasons could achieve. The original temple was covered in sheets of gold that the Spanish melted down and looted, but the stone beneath was already a treasure. The Spanish themselves were so impressed by the craftsmanship that they couldn't bring themselves to destroy these walls completely, instead incorporating them into their colonial construction. What's particularly interesting about Coricancha is that it shows how Inca construction techniques varied based on the importance of the structure. The outer walls use impressive stonework, but not quite at the level of the inner sanctuaries. The most sacred spaces received the finest workmanship, with the most precisely shaped and fitted stones. This hierarchical approach to construction quality tells you something about Inca priorities. The most important religious spaces deserve the most exquisite craftsmanship. You examine a section of wall where the original Inca stonework is visible. The stones here are almost perfectly rectangular, with joints so tight that they're barely visible. The surfaces are smooth and regular, showing evidence of extensive finishing work beyond basic shaping. This isn't just structural excellence, it's aesthetic refinement, a level of finish that goes beyond what's necessary for a stable wall and enters the realm of artistry. What's also striking is the consistency of the stonework. Every stone in this section is shaped and fitted to the same exacting standard. There's no variation in quality, no indication that different stonemasons with different skill levels worked on different sections. This suggests either a single highly skilled craftsman who worked on the entire wall, or, more likely, a team of stonemasons, all working to the same exacting standards, with quality control ensuring uniform excellence. The temple complex originally consisted of multiple chambers and courtyards, each dedicated to different aspects of Inca religion and cosmology. The walls you're examining would have surrounded spaces filled with golden artifacts, with the Inca emperor and high priests conducting rituals that connected the earthly and divine realms. The finest stonework wasn't just about creating beautiful spaces, it was about creating appropriate settings for the most sacred ceremonies, spaces worthy of the gods they honored. Archaeologists have found evidence that the construction of Coricancha represented a massive investment of resources and time. The finest stonework requires the most time and skill to produce, and a temple of this scale would have occupied master stonemasons for years, possibly decades. This investment reflects the central importance of this temple in Inca religion and politics. Coricancha wasn't just a religious site, it was the physical and spiritual center of the Inca Empire, the place where the Sapa Inca emperor maintained his connection to Inti, the sun god and divine ancestor of the Inca rulers. You notice something else about the stonework here, the way it integrates with other architectural features. Doorways and niches are framed with precisely cut stones that fit seamlessly into the surrounding walls. The transitions between different wall sections are handled with the same care as the primary wall surfaces. Even areas that would have been covered or hidden show evidence of careful finishing. This attention to detail, even in less visible areas, suggests that the quality of workmanship was valued for its own sake, not just for what could be seen. The temple also demonstrates Inca understanding of astronomy and cosmology. Certain architectural features align with celestial events, solstices, equinoxes, the movements of specific stars. The finest stonework wasn't just about craftsmanship, it was about creating precise alignments that connected the temple to the cosmos. This required not just skilled stonemasons but also astronomers and priests who could determine the correct orientations and dimensions. What you're appreciating now is that Inca architecture wasn't just about engineering, it was a synthesis of multiple knowledge systems. Stoneworking, astronomy, religion, and political symbolism all came together in spaces like Coricancha. The walls weren't just structural elements, they were cosmic diagrams, physical expressions of Inca understanding of the universe and their place within it. The finest craftsmanship was a form of religious devotion, a way of honoring the gods through the excellence of human work. The Spanish response to Coricancha is telling. They recognized both the religious significance of the site and the quality of the construction. Rather than completely destroying the Inca temple, they built their church directly on top of it, both physically and symbolically supplanting Inca religion with Christianity. But they couldn't bring themselves to destroy the finest Inca walls, instead incorporating them into the colonial construction. This reluctant respect for Inca craftsmanship acknowledges, despite cultural arrogance, the extraordinary quality of what they found. You examine a curved wall that shows particularly fine workmanship. The stones are shaped to follow a gentle curve, with each stone custom cut to maintain the consistent radius. Creating curved walls with rectangular stones is challenging enough. Creating curved walls with irregular polygonal stones is exponentially more difficult. Yet here it is, a perfectly smooth curve made from interlocking stones, each one custom shaped to contribute to the overall form. The temple complex also shows how Inca construction techniques evolved over time. The earliest sections of Coricancha show good but not exceptional stonework. Later sections show progressively finer technique, with the most recent additions likely from the final decades before the Spanish arrival showing the absolute pinnacle of Inca craftsmanship. This evolution suggests a culture that was continuously improving its techniques, not content with past achievements but constantly pushing toward greater precision and refinement. What you're seeing at Coricancha represents both the culmination of a long tradition and a hint of what might have come next if the Inca Empire had continued to develop uninterrupted. The finest stonework here is so exceptional that it's difficult to imagine how it could be improved. But the trajectory of Inca architecture suggests that they would have found ways to refine and perfect their techniques even further, pushing towards standards of excellence that we can barely imagine today. As you prepare to leave Coricancha, you find yourself reflecting on the relationship between technical skill and spiritual meaning. The Inca invested their finest craftsmanship in their most sacred spaces not because they were showing off, but because they understood technical excellence as a form of offering. The hours, days, and years of careful work that went into these walls were a kind of prayer, a way of honoring the divine through human effort and skill. This integration of technique and meaning is something that modern approaches to architecture and construction have largely lost, where efficiency and cost-effectiveness often trump other considerations. The walls of Coricancha survive today as both a technical achievement and a spiritual testament. They demonstrate what human beings can accomplish with sufficient time, skill, and dedication. And they remind us that architecture can be more than just shelter or monument. It can be a bridge between the earthly and the divine, a physical expression of cosmic understanding and religious devotion. The Inca stonemasons who built these walls weren't just skilled craftsmen, they were spiritual practitioners, using their tools as instruments of devotion. Leaving Cusco behind, you travel by train through the sacred valley, following the Urubamba River as it winds through the mountains. Your destination is the most famous Inca site of all, Machu Picchu. What you're about to see will transform your understanding of Inca architecture yet again, revealing dimensions of their engineering skill that are largely invisible to the casual visitor. The train ride itself is instructive. As you travel through the valley, you see the same pattern repeated again and again. Inca terraces climbing steep hillsides, transforming vertical landscapes into agricultural surfaces. These terraces aren't just aesthetic, they're sophisticated engineering features that prevent erosion, manage water flow, and create microclimates for growing crops. The same engineering philosophy that created earthquake-resistant walls also created these agricultural landscapes, working with natural forces rather than trying to dominate them. Machu Picchu appears gradually as the train approaches a complex of stone structures perched on a mountain ridge, surrounded by towering peaks on all sides. From a distance, it looks impossibly positioned, defying both gravity and practicality. But as you get closer and begin to explore, you realize that the site's apparent impracticality is actually a result of sophisticated adaptation to its specific location. You enter the site and your guide immediately draws your attention to something most visitors miss: the ground itself. What appears to be solid earth is actually an engineered foundation, a multi-layered system designed to provide stability and drainage in this challenging mountain environment. The Inca didn't simply place their buildings on the existing surface. They prepared elaborate foundations that would ensure the structure's stability for centuries. The foundation system starts deep below the surface. The Inca excavated down to bedrock and then built up in layers. First came a layer of large stones, creating a stable base. Above that came progressively smaller stones and gravel, creating a graded system that filters water and prevents the accumulation of moisture that could destabilize the structures. Above these stone layers came carefully prepared soil, providing a surface for construction and, in some areas, for gardening. This foundation system serves multiple purposes. It provides a stable base for construction, preventing settling or shifting that could damage the stone buildings. It manages drainage, allowing water to flow through the foundation without accumulating or causing erosion. And it creates a level surface on terrain that would otherwise be too steep or irregular for construction. The result is an artificial mountain flat, an engineered landscape that makes construction possible in locations that would otherwise be unsuitable. What's particularly impressive is the scale of this foundation work. Much of Machu Picchu is built on prepared terraces and platforms that aren't visible to the casual observer. You see the buildings and walls, but the massive earthworks that support them are largely hidden. Archaeologists estimate that as much as 60% of the construction effort at Machu Picchu went into preparing the foundations and terraces, work that is essentially invisible to modern visitors. The site also shows sophisticated water management. You notice channels running along pathways and through structures, part of a complex drainage system that manages both rainwater and natural springs. The Inca understood that in this tropical mountain environment, heavy rains could pose a serious threat to stone structures. Their solution wasn't to try to waterproof the buildings, but to create systems that would channel water away safely and prevent it from accumulating where it could cause damage. You climb to the agricultural terraces that surround the central complex. These aren't just decorative, they're functional growing spaces, with soil brought up from the valley below and carefully layered over stone drainage systems. The terraces also serve a structural function, stabilizing the slopes and preventing landslides that could threaten the main buildings. Like so much of Inca engineering, these terraces serve multiple purposes simultaneously: agricultural production, slope stabilization, and aesthetic landscaping. What becomes clear as you explore is that Machu Picchu isn't just a collection of buildings, it's a carefully engineered landscape where every element serves multiple functions. The agricultural terraces also stabilize the slopes. The water channels also provide irrigation. The stone walls also define sacred spaces. This multifunctional efficiency is characteristic of Inca design, where nothing serves only a single purpose and every element contributes to multiple goals. The site also demonstrates Inca understanding of their environment. The buildings are positioned to take advantage of natural light and wind patterns. The agricultural terraces are oriented to optimize sun exposure for different crops. Even the sacred sites align with significant mountains and astronomical features. This isn't just practical engineering, it's a deeply contextual architecture that responds to the specific characteristics of place. You visit the Temple of the Three Windows, a sacred space with 3 trapezoidal windows framing the mountains beyond. The stonework here is exceptional, with the characteristic Inca precision and attention to detail. But what's most remarkable is the alignment. The windows frame specific peaks and astronomical features, connecting the built environment with the natural landscape and the celestial sphere above. This integration of architecture, landscape, and cosmos is characteristic of Inca sacred spaces. Another remarkable feature is the Intihuatana stone, a ritual carved rock that served as an astronomical clock and calendar. The stone is positioned so that it casts different shadows at different times of year, marking solstices, equinoxes, and other significant celestial events. What's impressive is not just the astronomical knowledge required to create such a device, but the stonework itself, carving and shaping a rock in situ to create precise geometrical relationships with celestial movements. What you're appreciating now is that Inca architecture was never just about buildings. It was about creating integrated environments where human construction, natural landscape, and celestial movements formed a unified whole. The finest Inca sites aren't just collections of structures, they're complete worlds where every element has been carefully considered and placed in relationship to every other element. Machu Picchu also shows the adaptive nature of Inca construction. The stonework here varies based on function and location. Important religious and ceremonial structures receive the finest workmanship with precisely cut and fitted stones. Agricultural and utilitarian structures use rougher construction with less perfect fits. This variation suggests that the Inca were strategic about allocating their finest craftsmanship, reserving their best work for the most significant spaces. What's also remarkable about Machu Picchu is its preservation. The site was never discovered by the Spanish during their conquest, which means it wasn't looted or destroyed the way so many other Inca sites were. When it was rediscovered in the early 20th century, It was largely overgrown but fundamentally intact. This gives us a uniquely complete picture of Inca architecture at its peak, undistorted by colonial modifications or destruction. As you explore further, you notice that even small details show evidence of careful planning and execution. The stairs that connect different levels are precisely cut and consistently proportioned. The doorways are framed with special attention to the quality of stonework. Even the drainage channels are carefully shaped and fitted, despite being largely hidden from view. This attention to detail, at every scale, suggests a culture that valued quality regardless of visibility or recognition. The site also shows how Inca construction techniques were adapted to local conditions. The stone here is different from what you saw in Cusco granite, rather than limestone or diorite. The techniques are adapted accordingly, with different approaches to shaping and finishing appropriate to the harder material. But the fundamental principles remain the same: precise fits, interlocking shapes, and careful attention to foundation and drainage. What you're experiencing at Machu Picchu is Inca architecture in its ideal form, a complete, planned community where religious, administrative, residential, agricultural, and ceremonial functions are integrated into a unified landscape. The site wasn't thrown together haphazardly. It was carefully designed and executed over what was likely decades of construction, with each element considered in relation to every other element and to the larger landscape context. As the sun begins to set over Machu Picchu, casting long shadows across the stone structures and surrounding peaks, you find yourself feeling the same sense of wonder that visitors have experienced here for centuries. This isn't just an impressive archaeological site. It's a testament to what humans can accomplish when they combine technical skill with deep understanding of their environment, and when they take the long view, building for generations rather than for quick completion. Your journey through Inca architecture has taken you from the streets of Cusco to the quarries where stones were extracted, from the reconstruction sites where traditional techniques are being relearned, to the great complexes of Sacsayhuaman, Coricancha, and Machu Picchu. You've seen enough to understand that what the Inca accomplished was extraordinary, a testament to accumulated knowledge, patient craftsmanship, and sophisticated engineering. But as your exploration comes to an end, you find yourself reflecting on what we still don't know and what we may never fully understand. The more you've learned, the more you've come to appreciate how much knowledge has been lost. The Inca didn't write books about construction techniques. They didn't leave detailed architectural plans or technical manuals. Their knowledge existed in the minds and hands of skilled craftsmen, transmitted through apprenticeship and practice, rather than through documentation. When the Spanish arrived and disrupted Inca society, that lineage of knowledge was broken. We're left trying to reverse engineer techniques from the finished results, like trying to reconstruct a language from a few scattered sentences. Archaeologists and engineers continue to debate fundamental questions about Inca construction. How exactly did they achieve such precise fits between stones? The hammer and feather technique explains much, but not everything. The grinding theory remains controversial. Some details of their methods may simply be unknowable, lost along with the craftsmen who developed and perfected them. What we can say for certain is that they combined multiple techniques in sophisticated ways, adapting their approach based on specific circumstances and materials. The transportation of massive stones remains another area of ongoing research. We understand the basic principles: sleds, rollers, ramps, levers, human muscle power organized through sophisticated labor systems. But the logistics of moving 200 ton stones over rough terrain remain awe-inspiring even when we understand the techniques. The organizational challenge of coordinating thousands of workers in precise, synchronized effort is perhaps more impressive than any technical trick. How did they communicate over distances? How did they maintain coordination during complex operations? These questions about human organization are perhaps harder to answer than questions about tools and techniques. The timeline of construction also raises questions. Major Inca sites represent enormous investments of time and labor. Sacsayhuaman likely took decades to build, possibly spanning multiple generations of workers. Machu Picchu shows evidence of construction phases extending over many years. How was this long-term planning and execution managed? How did the Inca maintain continuity of vision and purpose across changing leadership and generational turnover? These questions touch on aspects of Inca society and governance that we understand only imperfectly. What's also mysterious is how construction techniques varied across the empire and evolved over time. You've seen that the finest stonework was reserved for the most important buildings, and that techniques improved over centuries. But how much variation existed between different regions? How did techniques evolve as the Inca incorporated new territories and encountered new building traditions? These questions about regional variation and historical development are difficult to answer from the archaeological record alone. The cultural context of Inca construction also remains partly enigmatic. We know that building was closely connected to religious and political priorities, that the finest stonework was a form of offering as much as a structural necessity. But the specific meanings and associations of different architectural features, the symbolic content of construction choices, these cultural dimensions, are harder to access from the physical remains alone. The Spanish destruction of sacred sites and melting of golden artifacts erased much of the symbolic context that would have helped us understand the full meaning of Inca architecture. Perhaps the most profound mystery is the knowledge itself. What did Inca stonemasons understand about stone, about physics, about engineering that we don't fully grasp? Their techniques weren't written down or diagrammed. They existed as embodied knowledge, learned through practice and transmitted through direct experience. This kind of knowledge is inherently difficult for outsiders to access, even more so when the lineage of transmission has been broken. We can see the results, but the specific insights and understandings that produce those results may be irretrievable. What's remarkable is that despite all these uncertainties and gaps in our knowledge, the Inca achievements remain undeniable. Their walls have stood for 5 centuries, outlasting the civilizations that conquered them and the modern technologies that were supposed to surpass them. In an age where we're accustomed to rapid obsolescence and planned replacement, the Inca commitment to building for eternity seems almost alien. They weren't interested in quick, temporary solutions. They invested in quality and durability, even when it required enormous time and effort. This brings you to a reflection on different kinds of knowledge and different ways of understanding the world. Modern knowledge tends to be explicit, theoretical, abstract, and easily transmissible through books and digital media. Traditional knowledge, of the kind the Inca stonemasons possessed, is often implicit, practical, embodied, and transmitted through direct experience. Neither approach is inherently superior, but they're different, and we've largely lost the ability to access certain kinds of traditional knowing. What you've witnessed over the course of this journey isn't just impressive construction, it's a different way of being in the world. The Inca saw themselves as part of a continuum that included past generations, the natural world, and the cosmic order. Their architecture wasn't just about building structures, it was about maintaining right relationships with all aspects of existence. The stones they worked with weren't just inert material, but participants in a larger cosmic drama. The Inca also had a fundamentally different relationship with time. They were comfortable thinking in terms of generations and centuries rather than years and quarters. A construction project that might span decades wasn't seen as prohibitively expensive, but as a worthwhile investment in something that would last. This long-term perspective enabled achievements that our short-term, efficiency-oriented culture struggles to comprehend, let alone replicate. As you prepare to leave the world of Inca architecture behind, you find yourself feeling a sense of gratitude that these structures have survived. They're not just architectural marvels, they're bridges to a different way of understanding the world, reminders that there are many paths to knowledge and many ways of being human. The Inca solved problems differently than we do, but their solutions were no less sophisticated for being different. In some ways, earthquake resistance, durability, harmony with landscape, they may have been more sophisticated. The continuing mystery of Inca construction techniques is frustrating in some ways. We want clear answers, definitive explanations, reproducible methods, but there's also value in not fully understanding, in being reminded that knowledge can take forms that resist complete documentation and transmission. The Inca walls stand as silent testimony to a way of knowing that we've largely lost, where understanding lives in practice rather than theory, in hands and eyes rather than books and computers. What remains with you as you conclude this journey is not just technical knowledge about how Inca walls were built, but a sense of awe at what humans can accomplish when they combine accumulated knowledge, patient craftsmanship, and long-term thinking. The Inca didn't have better tools than we have, arguably. They had much worse. What they had was a different relationship to time, to materials, and to the very purpose of building. They weren't building for the next quarter or the next election cycle. They were building for eternity, and eternity seems to have approved of their efforts. The mystery of how the Inca achieved their architectural marvels may never be fully solved. Some details may be forever lost, known only to the craftsmen who took their secrets to the grave. But what remains, the walls themselves, the testament to human ingenuity and perseverance, is enough. These structures speak across the centuries, not just about technical skill, but about what it means to be human, to create, to invest effort in things that outlast us. They remind us that we're part of a continuum, inheritors of knowledge from the past and creators of knowledge for the future. The stones continue to stand, long after the hands that shaped them have turned to dust. They've outlasted empires and ideologies, weathered earthquakes and the ravages of time. They continue to teach and inspire, challenging our assumptions about what's possible and inviting us to consider different ways of understanding the world. That may be the greatest mystery of all, not how the Inca built their walls, but how those walls continue to speak to us across the centuries, carrying knowledge and meaning that transcends the specific techniques of their construction. Closing. As we come to the end of our journey through the impossible architecture of the Inca, let yourself sink deeper into relaxation. The massive stones you've imagined, the precise fits that have puzzled scholars for centuries, the walls that have danced through earthquakes and stood firm for 500 years. Let these images settle softly in your mind, like stones finding their perfect place in a wall. Your eyes are growing heavier now, your breathing slower and deeper. Just as the Inca stonemasons worked with infinite patience, chipping away at stone after stone, day after day, you can allow your thoughts to settle gradually, gently, without urgency. There's no need to solve the mysteries tonight, no need to figure out exactly how those massive blocks were moved or precisely how those perfect fits were achieved. The answers, if they exist at all, will still be there tomorrow. For now, let the questions drift away like mist rising from the Andean mountains at dawn. Feel yourself becoming heavier, more relaxed, like a stone finding its resting place. Each muscle in your body can let go, tension flowing out of you like water through those ancient Inca drainage channels. Your shoulders drop, your jaw loosens, your breathing becomes slow and rhythmic, like the patient hammering of a stonemason shaping stone over hours, over days, over years. The Inca built for eternity, but you only need to let go for tonight. That's the beauty of their achievement. They created structures that have lasted for centuries, enduring through earthquakes and conquests and the relentless passage of time. And now, those same structures can serve a different purpose. They can be anchors for your imagination as you drift towards sleep, solid and enduring, peaceful and permanent. Imagine yourself now in one of those sacred spaces they created in Coricancha, perhaps, where the finest stonework was reserved for the most sacred purposes, or at Machu Picchu, where the interlocking stones support each other across the centuries. Feel the solidity beneath you, the precision and care that went into creating a space where you could rest completely, safely, supported by stone that has withstood everything time could throw at it. Your thoughts are becoming quieter now, less distinct, like the sound of distant water in an Inca channel, barely audible but constant and soothing. The day's concerns, the questions about how exactly they achieved what they achieved, the mysteries that may never be solved, all of this is fading into the background, replaced by a profound sense of peace, of connection to something larger and more enduring. The Inca understood that some things take time. Great walls aren't built in a day, perfect fits aren't achieved in an hour, and deep rest doesn't come from rushing. Allow yourself that same patience with your own sleep. Don't force it, don't rush toward it. Just let it come gradually, naturally, like the settling of a stone into its perfect place in the wall. You're safe, you're supported, you're drifting. The mysteries can wait until another day. For now, there's only the soft darkness, the gentle rhythm of your breathing, the gradual surrender into sleep. Like the interlocking stones of an Inca wall, your thoughts are finding their places, settling into position, creating a structure that will support you through the night and into whatever tomorrow brings. Good night, sleep well, and may your rest be as solid and enduring as the impossible walls we've explored together. 大鱼大鱼大鱼，全文结束，晚安。